So today we're going to take a look at section 3.2, which is Rolle's theorem and the mean value theorem. So these are very similar, and I think that there are some visuals here that can really help. Right? So starting with Rolle's theorem, there are some requirements that have to happen in order for Rolle's theorem to work. Right? And so those requirements are that it has to be, your function has to be continuous on the closed interval AB. It needs to be differentiable on the open interval AB. And then f of A needs to equal f of B. In other words, you need to have a horizontal secant. So what that looks like is a little bit like this. You have A and B, you find their points, you draw the secant line. It is a horizontal secant. If all of those things happen, what Rolle's theorem says is then f prime of C must exist for some value C in the interval AB, meaning there must be a point, an x value, between A and B where the tangent line is also horizontal. So what this is really doing is proving that there's an existence of an extreme value on the interval AB, meaning there's some sort of maximum or minimum there. So if we take a look at two examples with Rolle's theorem, right, we want to determine whether or not Rolle's theorem can be applied, and if it can, find all the values of C in the interval for which f prime of C equals 0. So when I look at this first one, f of x equals 3 minus the absolute value of x minus 3 on the interval 0, 6. I first want to check, is it continuous? And it is. And then I want to check if it's differentiable. In this case, it is not differentiable. We know that absolute value has a sharp turn, which is not differentiable. So really what we know that the limit as x approaches 3 from the right of the derivative does not equal the limit as x approaches 3 from the left of the derivative. And so because those are not equal, we do not have a differentiable function at x equals 3. Instead, we get that sharp turn, and so it cannot be applied. When I look at the second example here, f of x equals x to the 4th power minus 2x squared on the interval -2, 2. Right? We can utilize this example. Right? We have a polynomial function, so we know it's continuous. Sorry about that. We also know that it's differentiable. But again, you always want to check those first. Then what we want to do is see if we have a horizontal secant line. So f of -2 would be -2 to the 4th minus 2 times -2 squared. And that would be 16 minus 8, which is 8. And then we could find f of 2 and get 2 to the 4th minus 2 times 2 squared, which is again 16 minus 8, which is 8. So we have continuous, we have differentiable, and we have f of -2 equals f of 2. Therefore, we can apply Rolle's theorem, and now we need to find the derivative and find where the derivative is equal to 0. So f prime of x is equal, using the power rule here, 4x cubed minus 4x. We want to know when that's equal to 0, so 4x cubed minus 4x equal to 0. If I factor out a 4x, and then I keep going, I have difference of 2 squares. It looks like I get values of x at 0, -1, and +1. So again, Rolle's theorem guarantees at least one value. In this case, we found 3 values of C, right? Or in this case, we use X, but 3 values where the derivative is equal to 0. So here are the X values that we were looking for. The second part of section 3.2 is the mean value theorem. So if you notice, it's a very similar graph, right? There are still going to be some requirements that we must meet for mean value theorem. Those requirements are that, again, it must be continuous on the closed interval and differentiable on the open interval. The difference here is we do not need f of A to be equal to f of B. Instead, we can have a secant line that has a slope of some sort. If all of this happens, then what the mean value theorem says is that f prime of C must equal f of B minus f of A over B minus A. That's slope. So basically, it's saying that the derivative value must be equal to the slope of the secant line at some point. So again, A and B, we would find the slope, and then in between A and B, there exists a value C, where the slope of the tangent line is equal to the slope of that secant line. So again, taking a look at that of an example, determine all the values of C that satisfy the mean value theorem for the following function. F of x equals x cubed plus 2x squared minus x on the interval -1, 2. So the first thing that we need to do is check to make sure that this is continuous, which it is because it's a polynomial function, and also it's differentiable. And again, we know that because it's a polynomial function. So the next thing that we want to do is find the slope of this secant line. So that would be f of 2 minus f of -1 over 2 minus -1. When I plug in 2, I get 8 plus 8? No. Oh, sorry, minus x. I missed that. Sorry, 14. And then when I plug in -1, I get a value of 2. And 2 minus -1 is 3. So that 12 moved 3, that's 4. So we are now looking for where's the derivative equal to 4, because that's the slope of our secant line. So I need to find f prime of x. F prime of x is 3x squared plus 4x minus 1, which means f prime of c is 3c squared plus 4c minus 1. And again, what we are now doing is saying, where is this equal to 4? Right? In order to be able to solve that, right, I probably want to get it equal to 0. So let's move that 4 over. And then I always try and factor to see if I can easily find these values for C. Unfortunately, this quadratic is not factorable. Right? So then I've got to think of what are the other ways that I can solve to find these values of C. And the easiest way to do that is to use a quadratic formula. Right? C equals -b plus or minus the square root of b squared minus 4ac all over 2 times a. Right? So I plug in all those values, and I can go ahead now and clean that up a little bit. So -4 plus or minus, I get a 6 on the bottom. 16 minus -60 gives me a square root of 76. So again, it looks like we're going to get two values for C, right? I'm going to write them over here to the left. One is going to be where we subtract the square root of 76. The other one is going to be where we add the square root of 76. So when I calculate those decimals, and again, I would have to use a calculator, right? I would get negative 2.1196 and 0.7863. So I find two values for C here. However, I have to check them and make sure that they do apply to this function. If you go back to the beginning, we were on the interval -1, 2, which means this is not an answer that applies to this particular problem, but I can use my answer of 0.7863. So again, Rolle's theorem, the mean value theorem are ways to find certain values on intervals. Right? Rolle's theorem is almost like a specific case of the mean value theorem where that secant line has a slope of 0.